often also some issues. One of the issue is how to choose a value. If you take too small a neighborhood, it will not take a good estimate. You need more samples. If you take too large a neighborhood, then you lose the properties of the distribution. For example, if you take this large a neighborhood, every point is just the a priori probability. If your neighborhood is total number of points, then everything is that. Then you see that posteriori probabilities are nothing but the relative size of the classes, which, if you remember, is nothing but the prior probabilities. Okay, so it is a critical thing to choose what your case would be. Another important thing is that what I said that find k nearest neighbor, but when I say nearest neighbor, I have to define a distance between 2 points. So what is the distance? People have used the most common distance, of course, is the cosine similarity distance. You take the vector, take this vector, take the cosine. But that is not all. People take other kind like Jaccard coefficient or other type of distance measures people have used. But it is very important I mean, the entire shape of this decision boundary depend on what type of distance you are taking. Okay, so like one of the ways of choosing k, there are some principles. Like one of the thing is to avoid ties or binary classification problem. You take k to be an odd number, and also there is a thumb rule that as you increase the size of the sample, as you get more and more training set documents in training set, your k should increase. One rule is if you have capital N number of training samples, you take root n as your value of k, square root of n as your value of k. Okay, so if you draw the kn, see this kn is basically local boundary. So if you take a point, say take a point here, so this line I have plotted are actually the locus, the set of points which are equidistant from. So if you take the one nearest neighbor, they are equidistant from this both nearest neighbor. So they are ambiguous points. I mean, even k nearest neighbor would not be able to resolve which class to put in. Okay, but they indeed give a very sort of complex boundary if you. Okay, so like usually the thing is that this naive Bayes and other they work well when these classes are sort of unimodal. That means they are forming a single cluster. But it may happen that this blue, there are some more blue points over here also. So the centroid rule will definitely break down, because if there are some blue points here and some blue points here, the nearest neighbor would still give a good classification, but ratio, that centroid rule and naive Bayes would probably not give. There are disadvantages of nearest neighbor, because for each point when I find nearest neighbor, the time complexity is proportional to the total number of points in the training set, because you have to find out distance to every point and then sort the distances to find the top k. So the time complexity is indeed high. So that's one reason people sometimes avoid this. Whereas naive Bayes on the alternate is very fast. It is single pass. Yeah.
Sir, let's say we have binary class. We are classifying binary, and our k is, let's say, 11.
Okay.
Something, and we have 5 points which classify to one class and 6 are classified to other. But the 5 points are very close to that point, and rest 6 are farther from that point. So do we consider the importance of closer points?
Exactly. So this is used by what is called a Parchin window estimate. So what I do, I am taking k neighbors. I am taking a majority vote. So instead what I can do, I can take a weighted majority vote. So I do a voting, but a point which is closer to this yellow point has more vote than a point which is further away. The point which is further away has less vote. So vote is no longer a 0-1 quantity, but a real number. But the amount of vote is proportional, maybe an exponentially decaying thing. So further the distance, less the vote. So what I do, I calculate this real number votes, add them up over the red class points, add them up over the blue class points. and whichever is highest we will put it in that class. This is actually called a Hodgen window or a kernel estimate. Kernel classifier. Not kernel classifier, kernel nearest neighbor classifier. Okay, so these are some properties. No training is necessary, no feature selection is necessary. Scales well to large number of classes, which NAPES does not. Classes can influence each other. If there is a small new, it is very noisy. A new point added can change everything. May be expensive, but often it is more accurate than NAPES or Prof. Okay, so but one of the things, maybe these are technical terms I am not going to, that see the performance of these k-nears depends on which are the points I am taking in the training set, very much. If I take a new set of points, your classification accuracy may completely change, which is not true for NAPES. NAPES, since it is calculating some probability, the words are more or less similarly distributed. But here, since I am taking distance, the actual sample is very important. So this factor, that means the how much does accuracy change if I change the training set, is called the variance of the classifier. So if you take a nearest neighbor, if you change the training set, you have a large variance. Although the accuracy, the bias, the actual error, that is pretty low. Whereas in a NAPES, if you change the training set, the change in accuracy is not that much, but given any training set, there is a good amount of error, good amount of bias. There is a rule in classification which is called the bias variance trade-off. Any classifier which has a high variance will always have a low bias, and anything which has a low bias will always low variance will have a high bias. This is true for any classifier. So if you have a large training set, it is good to go for a low bias classifier. If you have a small training set, it is good to go for a low variance classifier. Okay, so one trade-off that people said that, okay, so there are two extremes. One is that this NAPES which makes complete assumptions, strict assumptions, independence, probability, and then does something. Whereas nearest neighbor, no assumption. Any distribution, take nearest neighbor, do it. Can I do something in between? Can I not be so stringent as NAPES? Can I not be so relaxed as k-nearest neighbor? Something in between. This gave rise to what I call, that means, if you take this, so nearest neighbor is free to choose any ragged boundary. NAPES is free to, actually NAPES gives only circular boundaries. Then I have something in between. So one thing people did is that, okay, let's do like this. Let's try some particular families of shapes. That means these boundaries will be of a particular curve, a known curve. The first curve people thought about was a line, a straight line. They said that, can I draw a linear discriminant which separates the classes? Can I draw a linear discriminant? Okay. This approach gave rise to one of the most popular approach in text classification today, the support vector mixing approach. Let me go into that. Okay. So the idea is like this. So initially, let's say there are only two classes, say span and non-span, and documents as points. Okay. So what I have to do is that I have to draw, if there are two classes, you can imagine that one single line will be able to separate them. Only one single line, two classes will be able to, but how do I place the line? What is the slope of the line? What is the position of the line? So one criteria that is required is that this line should be such placed that all these, so suppose these are two classes, so I have to place a line x plus by equal to c, and I have to find ABC such that all these red points are in one side of the line and all the green points are on the other side of the line. Okay, that criteria is required. So I'm coming into this second criteria. Can you tell me? So suppose I call these points as xi and the corresponding class level as yi. So can you give me a condition on A, B and C so that all the, and say if there are two classes, this yi for one class I can call as +1 and in the other class I can call as -1. Say only two classes, right? And let me take, without loss of generality, take one more thing, that you know the point, suppose this is my line, this one is my line, the points which are on the, if somewhere here is the origin, the points are here which are on the non-origin side, I put their class level as +2. Yeah.
Sir, most of us are aware of all the pattern recognition techniques. What we don't know is how these things apply in text classification, what is the pluses and minuses of each one of the approaches and so on. We know the basics of pattern recognition, and I am not sure if we can cover the entire pattern recognition area in another half an hour.
Okay, all right. So, okay, so I can do two things. What I can do is that if I, so can I assume that you know the, you know the basic? Okay, let me do one thing. In 5 minutes, let me quickly wrap this up. So, what finally we get, then we will go into the actual details of what can be applied. So the final story is like this. Like what you actually want is that you want a line which is a good separator between these two. And one of the criteria, and it is not enough that the line is so placed that all blue or all the green are on this side, the red are on this side. What is also required is that the line has a good separation boundary, a margin. So that means if we around the line I place a strip like this, no blue or red point would lie in that strip. You note that the further you change the, so if I define the strip as, if we take the center of this strip as a line and the width of the strip as the distance to the closest point, then you can see that only the line which will have the highest widest strip is the one passing through the middle. Any other slope line will have a smaller strip. Okay. So for example, if I take a line like this, it will have a much smaller strip. Okay. So the support vector machine, what it does is that it uses a set of optimization tools which actually gives you the slope and the position of the line which has the largest margin. It is also, that's why sometimes called the large margin classifier. Okay, so I am skipping all this, and the points with the vectors which are lying on the boundaries of these strips are called the support vectors. Right? So I am skipping all this. It is formulated as a quadratic programming problem. So if you can define margin and then do some optimization steps and finally do this. Okay. So and also okay, all this. Also, like there is a small modification to this where if the classes are overlapping, you cannot have any strip. So what you do, you have a soft strip. That means you allow points to lie in this strip, but you penalize such crossings into the strip by a factor in the optimization function. Okay. So as a result, you get the large margin, soft margin classifier. So again, I am flipping all this, skipping all this. So what is probably a little more important is that you can apply these same principles to get non-linear boundaries and not just linear boundaries. Okay. The trick is that if you project a smaller dimensional point to a large dimensional point, if it is non-linearly separable in the small dimension, it's still, if you take a proper mapping, it becomes linearly separable in the higher dimension. And accordingly, people have proposed several kind of mapping functions, sometimes called kernels, which takes into high dimension where it becomes linearly separable. Okay, so these are, I'll quickly tell you. So the simplest kernel is a line. There are polynomial kernels of this particular form. So a kernel function can be thought of, the linear kernel can be thought of as the cosine of the angle between the two vectors. And similarly, the polynomial kernel can be thought of some function of the cosine of the angle, dot product of the two vectors. So, similarly, you have a radial basis function kernel, which is e to the power the Euclidean distance between the two vectors. What is useful in text finding is that if you take this view, you sort of move away from a vector space representation of a state. You just need two different. You need a function which establishes closeness of two text documents. Closeness of two text documents, and once that closeness is computed, you form what is called a kernel matrix and apply all these optimization techniques, and you get a linear subscribe. Okay, so in text finding, people have okay, I'll tell. So what can be done is that, so people have proposed different kind of kernels which are suited for text classification. The first kernel that was used is called a string kernel. The string kernel is like if you are given two strings of text, how do you define a similarity between these? The trick is just like earlier in a bag of words, a document is represented by a collection of words. In a string kernel, a document is viewed as a collection of sequences of words. So you have a vector space representation where the components of the vectors are not words but sequences. And it can be shown that this is equivalent if we take this string view and take the cosine similarity on the string substring representation. It is equivalent to having a kernel function where if you take two documents and their similarity is nothing but you slide the words, you shift the words in one, take two documents as two strings of words, you will slide the words and put them side by side if they match or not. That means under movements, if there are common substrings in these two texts. So in this kernel trick, I can find out similarity between two texts as two documents as the number of common substrings shared between them. So that gives a kernel trick. Another place where where kernels have been adopted is called a graph kernel, where your objects are graphs. The similarity between two graphs. So kernel is you take any object of a particular mathematical form, a vector or a graph or a string, you find out some similarity, some measures of closeness of these two. In the simplest closeness is what you have taken in vector space is the number of common words. Little more sophisticated is number of common substrings, which does have with the independence assumption, position independence assumption. A little more complex where you have HTMLs and XML files which have a tree structure or a graph structure, you can take number of common substrees in this XML. One of the common way, another thing I did not talk about is that all these classification methods I talked about are for unstructured text. The text is a collection of words. But some texts like HTML, XML, they have some structuring information. There are paragraph and sections and such information. Okay, or in case of medical and other document, there are tags, XML tags. So this structure is also important sometimes in a classification process. So this XML, this can be represented as DOM trees, document object model trees, and kernels have been redefined for such XMLs where you can find similarity. A normal bag of word or net page would fail in such schemes. Okay, so unfortunately, I do not have comparison studies, but maybe what I can sum or okay, maybe how much time? I have a lot of time. Maybe I should talk a bit on. And then conclude. evaluate this method? The methods of evaluation that works for retrieval has to be changed here. Of course, the basic method, I mean basic score is what is called a classification accuracy. That means if there are n samples to be classified, if r of them are correctly classified, it is called a. So usually what you do, you create what is called a confusion matrix. That means where you have a matrix where the rows are the predicted class and the columns are the actual class. The diagonal entries of this matrix are the correctly classified, so that fraction is the classification accuracy. But what is more important is that this classification accuracy would depend on the test set you are taking. And there is a phenomenon in classification called overfitting. That means you can actually go on training, fitting better and better the training set and get good accuracy on the training set, but perform poorly on the test set. Okay, so in classification, there is always a step which is not there in retrieval, is called a cross validation. So instead of testing on a single test set, you take several different test set, so maybe 10-fold or 5-fold, and calculate the accuracy of each of these. And when the average accuracy and the variation of the accuracies over this 10-fold cross validation is satisfactory, only then you stop training. So this is a important test, and this is a few experiment. This is pretty dated, which was done on the web pages. This was called a WebKB experiment. It was done in web pages in few universities, and it was trained on them. And then for a new university, when the pages were given and tested using NAPBase, each of these categories had a kind of accuracy like this. So this actually was a good thing for NAPBase. And then these were the words word probabilities which are found useful for NAPBase for such techniques. Unfortunately, I don't have other methods. Maybe I should have had them. Okay, but one important, to give you a flavor of how if you want to build a real classification engine, what you have to do is that, say, one of the most popular places where it is used is called a spam filter. Yeah.
Instead of that 10-fold cross validation, if we have large data set, can we just use just one-fold cross validation? Just randomly dividing data into training and test set.
Yeah, so there is a equivalence. Actually, you can show that getting a 1000 set data and doing estimating the error probability based on that is sometimes worse than taking 100 size data separately and counting this. Oh no, but if you take the average, it is the same, but the variance will be different. So that might be done. Okay, so there are different ways. So cross validation is one way. Another is called a holdout set. So there is one test set plus another holdout set where you stop your training based on performance of the test set, but you actually compute the accuracy on that holdout set. Okay, so these are possibilities. So there are different ways.
Actually, my question was this holdout set and cross validation, like n-fold cross validation. So in which cases do we use n-fold cross validation when we use holdout set?
So usually their scores agree. If you take a 10-fold cross validation, the scores should agree with a holdout set. If you have a large holdout set, if the sets are large, okay. But if your training sets are small, then they might not agree. So which one you take to be better is difficult to tell. That depends on the classifier. If you have a high variance classifier, then holdout is better. High variance, low bias classifier. If you have a low variance, high bias classifier, then a cross-fold 10-fold cross validation is probably better. For exactly text, I'll maybe upload in the supplementary material. For for text what performance has been observed. Okay. Alright, so if you actually want to build a classification, it is not just building a classifier. Okay, the steps are as following. First, you have to collect all the features that will help you in classification. What are the word features? What are the sequence features? If there are often there are many external features like timestamp and author of the document, or maybe source of the document, or maybe in the case of spam, the URL from where it is coming, or maybe hand-captured text patterns in the case of spam. So all these are taken into account. Then, for the spam, for example, this is a popular spam assassin open source. All these are used. So there are some basic name-based probability. There are some typical words, some regular expressions of a particular form which are common in thing, some phrases, some numeral patterns. Actually, in spam classification, numeral patterns are many times dollars, and all the symbols are very important. HTML to image to, there are several features which are domain specific, which are used. So this is the most important step. Then what usually people does, they use a host of techniques. So they use a host of techniques and maybe use a combination of this. So if we summarize, let me summarize and go into some open source. Yeah. So if we summarize, the overall problem of text classification is usually the difference with other pattern classification is usually it is very high dimensional. You should, because of this dimensionality, you should prevent high bias algorithms which have a high bias like nearest neighbor. There are many relevant features as well as there are many irrelevant ones. So feature selection is very important. There is no optimal learning technique. Depends on the problem you are taking. It depends on the features you are taking. So some of the factors that you have to take into account by deciding which text classification algorithm to use is the amount of training data, the class shape of the class boundary, whether it is linear or circular, how complex the decision boundary is, how much noisy the data is. Say, there are a lot of spelling errors like SMS and other, and what is the dynamic nature of the problem? Like spam classification, one problem is you build a classifier, within 2-3 days the spammers beat it by changing their spamming words. So it has to be very dynamic. Or similarly, for example, dynamic content like Twitter and others, the content changes very fast. So you have to change your algorithm. So name-based and others provide a way of doing this by changing the a priori probabilities, and the class conditions are factored out so that it can be updated easily. But the feature set may change, the structure of the document may change. So all this has to be taken into account. Okay. So in conclusion, there are a number of applications. There are many different algorithms. None of them are the best. You have to choose which one to be taken. The topical text classification problems are easy. The non-topical ones are relatively more difficult. If you are want to use text classification, there is a setup. So there are open source, just like you have Terrier and Smart. Lemur and Indri has all these probabilistic classification algorithms built in. The SVM Lite and others have all the SVM and all the SVM algorithms built in. And there are many text classification tools for large data like Mahout, and there is one more called Mallet, which has not just classification but other tools which you can use and which has all these basic vector space and other representations built into it.
Is time complexity a factor by choosing algorithm?
Nearest neighbor is the most time consuming. Naive Bayes is the fastest. Support vector machine is in between. but to give you an idea, if you take a spam classification problem of a typical email service like Yahoo and others, they use support vector machine. But most of the large classification tasks rely on a distributed framework, distributed computing framework. They use a Hadoop or a MapReduce kind of thing, where most of these algorithms are ported to MapReduce architecture also. So you can, since they have to be very fast, something which has to be, so they use a large MapReduce architecture. And naive-Bayes and others are very easily portable to a MapReduce architecture. Support vector machine also has been recently ported to MapReduce architecture. KNN can be ported, but KNN performance as you increase the size of the thing falls. There is another approach I didn't talk about, it's called boosting, which AdaBoost approach. There was an experiment by Bell Labs where support vector machine naive-Bayes and boosting was compared. Naive-Bayes was poorer, but support vector machine and boosting AdaBoost performed close, very close, it cannot be differentiated. Currently SVM is the most popular, mainly because of the many fast implementations and can be handcrafted. But naive-Bayes is also used. But one thing is that it is not just the classifier, rather more important is the feature set you use for the text classification. You take a new problem, you have to craft your own feature set, which is a more critical thing.